Just a quick reminder before we get into the lesson to download the hands-on lab exercises that accompany this complete CCNA course. I'll include the link in the description. Also remember to subscribe and hit the notifications bell so you don't miss any of the lessons in the course. Okay, let's get into it. In this lecture, you'll learn about spanning tree Portfast and BPDU guard. So first one we'll cover is Portfast. It can take up to 50 seconds for spanning tree to transition a port to a forwarding state when that port becomes active by powering on the switch or plugging a network cable into it. So that's a long time. And if you think about it, a loop cannot be formed on ports where a single end host is plugged in. So if you see the diagram at the bottom here, I do have a potential loop between my three switches there. So one of the ports was put into a blocking state. I then go and plug a PC into one of the switches with a single network cable connecting it. Well, it's impossible to have a loop going through there as long as it doesn't change. So it would be nice if I didn't have to wait 50 seconds for the port to come up. And you can actually configure that. So you can make the port transition to a forwarding state immediately when it becomes active by disabling spanning tree on the port. The way you do that is with the Portfast command. So this is configured at the interface level. So here my PC is plugged in interface fast 0/10. At the interface config, I say spanning tree Portfast. It disables spanning tree from running on the port, and it will transition to forwarding immediately. You can also set all of your ports to be Portfast by default. To do that at global config, the command is spanning tree Portfast default. Then just make sure that on any ports that are connected to switches, enter the command no spanning tree Portfast on those ports. Now, hopefully it's quite obvious that there could be a big problem with this, because if you enable Portfast on a port, you're disabling spanning tree, and if a loop is formed through it, then you're going to get a broadcast storm. And this could happen. The most common reason is users doing things that they shouldn't be doing, like adding devices to the network, like additional switches, or changing the cabling. And you can see that's what's happened in the diagram here. We've got our switches up at the top are configured with Portfast, and we expect normally it's end hosts that get plugged in there, but probably what happened was there's some part of the building where there's not enough wall ports. So a user has come in with their own switch and they've plugged that into two different wall ports in that part of the office to get more ports for the additional users that are there. And by doing that, they've formed a loop. But you can see the loop that is formed there, and now you're going to get a broadcast storm. So it's dangerous enabling Portfast. So we want to take some mitigation against this kind of problem happening, and that is where BPDU guard comes in. So you can enable BPDU guard on the same interfaces where you've enabled Portfast. And then if a BPDU is received, the port will be shut down. Remember, switches, when they come online, they send BPDUs out all ports to build the spanning tree. So if you do plug a switch into a port, it will receive a BPDU on there, and this can allow the switch to automatically shut down that port to prevent a loop from happening. The command to enable BPDU guard, so it's the same example we had before. We've got interface fast 0/10, spanning tree Portfast. We put the additional command on there, spanning tree BPDU guard enable. And it is best practice to use these commands on your networks where you've got ports that end hosts are going to be plugged into. Just like we could with Portfast, you can also make BPDU guard the global default. To do that, in global config, spanning tree Portfast BPDU guard default. Another spanning tree command to cover is root guard, and this is used for a different reason than Portfast and BPDU guard are. Spanning tree root guard prevents an unintended switch from becoming the root bridge. So say, for example, that you have an old switch which had been in a different office and it happened to be the root bridge in that different office. But it's a much older switch than the root bridge which is in your main office. So you get that old switch shipped back to the main office, and then you don't do a factory reset on there. You plug it into the network and it happens to have a higher priority than the current root bridge. Well, now that old switch, which is not going to be in a central part of the network, is going to become the root bridge. So you want to make sure that that does not happen. Another reason that the wrong switch could become a root bridge is maybe that you're under an attack. And what the attacker is doing is putting a switch into the network, trying to make that the root bridge to force traffic to come through the switch that they're controlling. They'll then be able to sniff the traffic and gain access to sensitive information. So if you want to make sure that the current root bridge remains the root bridge, which you normally will do, you can use RootGuard to help ensure that. The way it works is that if a port where RootGuard is enabled receives BPDUs that are superior than the current root bridge, it will transition that port to root inconsistent, meaning that no traffic will be forwarded over that port. And the way that you configure this is on the interface, you say spanning tree guard root. So in the example on the slide here, we've got our root bridge up in the top left. This is the one that we want to remain the root bridge. And what we do is on the port here and the port here, we configure spanning tree guard root so that if the switch at the bottom starts sending out superior BPDUs, they are not going to be accepted, and the port that is connected to that switch is going to be transitioned to root inconsistent, basically shutting the port down. Okay, that was everything to tell you for spanning tree. We got through it. See you in the next section. Thanks for watching. If you'd like to get the complete course ad-free right now, then you can enroll in my CCNA Gold Bootcamp by clicking the link above my head or in the description. It also includes full study notes, quizzes, and 150 pages of additional troubleshooting labs you can't find anywhere else.